Free any question. I'm sure it'll be third. What'd you say? Number 3? 3 part B. Oh my goodness. So, yeah. I'm going to go ahead with part B since it's... So because I'm taking the derivative of an integral, those are essentially opposite operations, right? But I've got f of t evaluated here with an x in it. Now, several of you went through and you did, because you had f of x. F of x is 4x minus 9. And you went through and you found the antiderivative and you did the fundamental theorem by plugging this in and then plugging that in and then subtracting. But what you forgot was it's not asking you to evaluate this. It's asking you to find the derivative of that. And so you got all the way down and that was right. And had you taken the derivative of your answer, it would have been right. Because you didn't take. Does that make sense? This part B. So even though you did a lot more work, it still would have worked if you'd remembered, well, wait, I have to take the derivative of that. Now, with that said, the shortcut, or not even the shortcut, but the fundamental theorem says we can take this f of x and replace, since I'm doing f of t here, replace that variable with the negative 5x squared, right? So get 4 times negative 5x squared minus 9. But then I have to chain rule it because this has a chain. You could have left it just like that and been A-okay. Could have multiplied it out. Yeah. Risk messing up. So you did, antiderivative is 2x squared minus 9x. Plugged in negative 5x squared, plugged in negative 3 and subtracted. It'll come back out. It's like, I can't remember what it is. But yeah. So I circled d dx on some of yours. And then part A. So you went from negative 1 to x. This one you could not just plug an x in because I'm not taking the derivative here. This is just straight chain rule. It says if this equals from 3 to x, f of t dt, find k. Well, regardless or not, if these equal, right, and I'm finding the antiderivative, when I plug in x, I'm getting the same thing. Do you all agree with that? So I'm not even going to write that because that's more work for me. But I am going to subtract, and then I'm going to plug in. Remember we said the antiderivative was, what was it? 2x squared minus 9x. I'm going to plug in negative 1. 2 times negative 1 squared. You see why I have a negative in front of there, though? Yes, 1 second. And then I'm going to plug in a 3. I'm just showing you. Now, I could drop them now since they're both negative. But the reason is because if I plugged in x here, then I would have 2x squared minus 9x minus, so you do upper bound minus lower bound. But because these will be the same on both sides. Excuse me. They're just gone. I can also take a negative from both sides. So those are gone. So I end up with 2 times 1 plus 9 plus k equals 2 times 9 minus 27. I'll just solve it for k. I don't know what 18 minus 27 is. 9. I should know that. That's right. Negative 9. Right? positive 20 there? Where did I get a sign error? I think it's supposed to be negative 20. I think I messed up on my answer. No? Well, but the reason it's negative, oh, look, I can't just drop these negatives off like that unless I change this sign also. If I divide both sides by -1, that's why. Woo! So negative k, so k is positive 1. Let me just a minute. This k is not in that parenthesis, so I can't just drop a negative like that. If I divide both sides by -1, this negative goes, this changes the sign. That's why. My bad. All right, other questions about that page? Number 1 was area. It was a trapezoid. We did one exactly like that in class. Number 2 was so that you knew you can't do multiplication. Let's see, how about on the back? Particle motion. 4b. What's the particle's position at t equals 3? So it says that position at any time is equal to the integral from 0 to t of f of x dx. So if I want to know what's the particle's position at 3, I want to know s of 3, which is from 0 to 3 of f of x dx. So look at your graph there, and from 0 to 3, it looks like a trapezoid. Do you agree? Something like this. This height looks to be about 2.5. This height looks to be, actually I know that this is 3,1, so this height is 1. I say height, but really it's, and this length is 3. So 1/2 height, which is 3, and then add the two bases together. 5 1/4. E. Yeah. Part E asks what time during the first 7 seconds does it have the largest value? Looks like this. This is 3,1. Although this is. And so I said, okay, well, this ended up looking like this cross about 3.5. I did take a couple points off if you said the first 3 seconds, because if you look at the picture, this comes down, there's still some more positive area here that you can tell. So I wanted you to realize that it went past there. But you're looking during the first 7 seconds, and 7 ends up being like right somewhere around here. The most positive area happens at this point. The most positive area, correct. Right. Anything else?
So that's the largest area. So what happens to the project?
Well, remember you're looking at velocity, right? And so when you cross, so when you're talking about area, this just means instead of moving to the right, I'm now moving to the left. So now it's right. So at 3.5 seconds, it changes direction. I'm going to beat y'all over the head about number 6. Now, some of you, and I was very nice and gave you partial credit, some of you recognize that the antiderivative here was secant x, because the derivative of secant x is secant x tangent x. And so you wrote secant x from 0 to pi over 3. And you did secant pi over 3 minus secant 0, and then you stopped because you did not know those values. No, that's exactly right. That's exactly right. Was this calculator or non-calculator? This was non-calculator. Well, so whenever I did it, I really did have to think about where's pi over 3. And I always have to think about, I know that secant is 1 over cosine, so what's the cosine value there? And I have to picture them at pi over 3. Is it longer this way or is it longer this? You know what I'm saying? So I know which one's 1/2 and which one's square root of 3 over 6. So, absolutely, I have to do that sometimes. Sometimes your brain just shuts down. Yeah. Listen, and if you have to come here and go do the 1, 2, 3, 1, 2, 3, I mean, whatever you got to do to get it, yeah, whatever you got to do to get it. Yes. So the cosine at pi over 3 is 1/2, so the secant would be 2. What's the cosine at 0? 1. You all should have been able to at least get that one. And then 2 minus 1 is, of course, 1. That's not always the answer. That's what y'all always think is the answer. All right, y'all good on non-calculator? Calculator part, I was a little embarrassed about how sloppy and nasty that I didn't go back and erase those 2 questions, but sorry. But regardless, any questions on the front? Y'all did way worse on the calculator section, if I recall correctly. You did on the non. And I don't know if it's because I made you write so much out, even though it was calculator or what, but biggest problem I remember on number 2 was you didn't read the question carefully enough. It says left endpoints. On your review packet, it was right endpoints. So it was a little bit different.
So if you don't go to
You either put all of them or you didn't start at 0, you started at 1/2. If you started at 0, you don't include 2.5, that's left. If you did right, then you'd start at 1/2 and you would include 2.5. 30.9277 or 9.845 pi. And again, if it's a calculator problem, I put that equation in y equals, and then I go into my table and I type those. What do you mean? 7 points. I think I took 3 or either 4 off if you used the wrong endpoints. But everything else was correct. And I think, I can't remember. That was the one thing that kind of overlapped with people that most people do. Okay, let's talk about number 3. I think I know why the argument occurred. It's because of the way I worked it on the review. So I think you didn't understand. You're trying to follow an exact pattern for what I did rather than understanding what, you see what I'm saying? So let's think about this for just a second. I've got this graph. Now, this looks different than the one on your review, right? Because I think the one on your review did something like this. right? Okay. So part B, everybody was good, right? That was just plug and chug in your calculator. Show me the integral setup. I didn't even take off if you didn't show me the antiderivative. If you just showed me the integral setup and then told me what it equaled, so that was -6. But part C asked you to find the area. And remember, area and integral are different. Area means everything has to stay positive, right? So this point was 5, I think. Yeah. So we had to divide it up into 2. So this is the integral from 0 to 5 of whatever this function is. This is the integral from 5 to 6 of whatever this function is. The one that's going to give you the negative area is the one that you're going to subtract, and I think that's what I did on the review is I subtracted it. But really the reason I subtracted it was because you have to make it negative. You have to take the opposite sign since it's going to come out negative. It looked like I was subtracting because they were flip-flopped before, right? So if it was like this, then this would be from 0 to 5 f of x, and this would be negative 5 to 6 f of x. And so when you add those together, it looks like you're subtracting them, which I mean, essentially you are, but that's the reason. Here, because this one comes first, this is the negative one. Does that make sense? The negative of the negative area?
I just knew it was negative because it was
Or you could say the absolute value of the integral from 0 to 5 of f of x dx plus for any of what?
you end up getting the absolute value of -6.7.
So this was 6 2/3. It was negative, but you make it positive, and then to that you add 2/3 here. So it's 7 1/3. I don't know. I'll go back and look. I'll compare what I did to others. Y'all good? I can't tell by the looks on y'all. Okay. Yes. If it ever uses the word area, that is always positive. If it's the area, if it says the area, we're talking positive. If it says just evaluate the integral, then we can be negative. Y'all okay? All right, and this was calculator, so definitely use your calculator to check it. Y'all know how to graph it and then second trace and do the integral there. It'll shade it for you and everything. And the only thing you'll have to do is, obviously, it'll give you a negative value here, make it positive. So we went from 0 to 2, 0, a half, 1, 1 1/2, and 2. Again, this was calculator, so put that in your y equals there and go to the table. And then 1/2, and then the width was 1/2, so you're multiplying by a fourth in front. 2.981. I don't have a calculator. I'll check it though. I'll look. Anything else? We will. Let me go over homework questions, then we'll chill out for a minute before I talk to you about use substitution. Number 5. No, natural log of 5 is a constant. Remember that. Does that answer your question? Okay. Antiderivative. So look at your derivative sheet, first of all. There's one of them on there, I think it's a to the x. What's the derivative of a to the x? What is it?
I didn't know that.
So the antiderivative here would be 5 to the x plus, and this looks like another one of those inverse tan.
We're looking at right there is the derivative.
Right, that's correct. Just don't forget that plus c because we don't know, we don't have an initial value. Yeah, don't forget. Bless you. Unfortunately, you will lose points on FRQ if you don't have that plus c. 21, you said? Dy dx equals sine x squared when y equals 5 and x equals 1. What did it say? Did I give y'all those? I felt like I didn't. Did I give them to you? Bless you. Did I? Solve the initial value problem using the fundamental theorem. Your answer will contain a definite integral. So on these, all you're doing when you set them up is you're going back. This is kind of the backwards of the ddx that you did, like on your ddx of the integral that you did on your homework. So we're just going to say that y equals from this value, right? So from 1 up to some other value of x. We're going to change this to a t, and then this value is my constant that I add on the end. You really don't have to, don't worry if that doesn't make a whole lot of sense to you right now. Do I? Because I want to be able to include some arbitrary value here, and I want it to be a variable, and if this were x instead of t, it wouldn't make any sense. So I changed the variable up. 23 is the same kind of thing. 23, this is the derivative of the antiderivative, which means what? It's just the function. It's just the function. That's exactly right. So that is the function here. So I'm going to do, and it tells you that f of 2 is 9. So I'm going to go from 2 to x, right? E to the cosine t dt. What am I going to add on the end? The 9. Anything else? How were the 25 through 34s where you were matching, or 25 through 40? Where you matched the graphs to the slope fields? Those were okay? Okay. All right, I'll give you a little break as promised. Indefinite integrals don't have limits, upper bounds or lower bounds. They're just a general. So for indefinite integrals, I cannot forget the constant on the end. Don't forget the c. Now, with that said, the properties of definite integrals are the same as the properties of the indefinite integrals. As far as pulling the constant, I'm not going to go over all of those unless you guys need me. Pulling the constant out in front, if you're adding or subtracting, you can split them up and so on and so forth. There are a couple, and these are on your derivative sheet. No, you'll just need it one time. Oh, you'll just need it. I don't have a derivative sheet up here with me, but you all have the derivative sheets that I ran you on the colored paper yesterday. A couple of new ones, I'm pretty sure. If you have u to the x dx, is that one on there? No, no. Wait, this is not one on there. Who's got a derivative sheet? I can look at. not doing integration by parts. Oh, I did put it on there. If you have the integral of u, and we're going to talk a lot about that u in here, u to the n du, the antiderivative here is u to the n plus 1. Oh, this is what you've already been doing. Do you see that? How did we get that? Let's look at it. Let's look at, this is fancy speak for doing what you've already been doing. If you have x to the third dx, what's the antiderivative? 1/4 x to the fourth. So your base stays the same. You add 1 to the exponent. You divide by that exponent. It's the same thing you've been doing. It just looks bleh, right? And then the plus sigma. Thank you. Trying to think of any others that I might need to. They're all on there for you, though. You just have to memorize them. So you tell me what would be that, the integral of u to the negative 1 du. Y'all should know that. I did the absolute value of the u here because it can't be negative. You can't do, if log is a base of e, right, you're not going to be able to raise anything, e to the anything power here to get a negative number, so u has to be positive to do the absolute value. How about the integral of the natural log of u? This one's a little bit harder. And I'm using u's intentionally, and you'll see why in just a second. Any idea? This one you wouldn't just recognize. You'd have to use your sheet. It'll be something that the more you do, the more you'll see. Look at the integral side of your sheet. Y'all are killing me, Smalls. That's the antiderivative there. If you were to go backwards, you would see that you come back here. It should be on there, the integral of the natural log of u. Why is that the integral? Okay, so if I come here and I do the derivative, okay, so derivative of the first times the second, it's right because it's a product. This is just a memorized thing. Yes, just memorize it. Just memorize it. Yeah. I'm putting all these u's in here because what's going to happen is we're going to have to find, the u is not going to be u as we do it. The u might be something like 2x squared plus 3x plus 5, and we have to derive, or we have to integrate with that. We're going to have to sub it out because it's going to be too hard. Let me show you what, maybe I should have started like this instead of starting with those. And we kind of started talking about this a little bit yesterday. But this really is a big, big topic, substitution. Because a lot of these, the only way to do it is to do substitution. It's the easiest way to see it. So let's say I asked you to evaluate the integral of sine x e to the cosine x. I feel like we did this one yesterday. Did we? In this case, and most of the time what you're going to be doing in something like this is you're going to be letting one of the trig functions be your u, okay? So here, if I said, okay, well, let's let u be cosine of x. What would the derivative here, in other words, the du, be? Everybody agree with that? So do you agree then that I could rewrite this as the integral of e to the u? There's e to the u. The only difference is this negative here, right? I need to add that negative in there in order to make that right. That's my du, right? Du, but I need a negative.
Why did we just get rid of it?
Well, you have to find the antiderivative, right?
So what if it's a completely different thing?
You have to decide which one to make u and which one. So what you'll do is you'll find a u, okay? Always start with your trig functions. And you'll have to kind of look at it to see which one looks like the derivative of the other one to find it, okay? So you'll have, and this is a really basic example. This one you don't really need u substitution to do because we did it yesterday without u substitution, but just to show you what USub is doing. So I choose it, and then what it does is it allows me to find the integral of a simpler function. In other words, I have negative e to the u, right? Well, I can take that negative out, and what is the derivative of e to the u? E to the u. So I just have negative e to the u. Now I can go back in. That's one of those properties. I can just put it on the outside.
So what does it do by moving to the outside?
You don't necessarily have to, no. I got to do my plus c because it's an indefinite integral. And then you plug the u back in. So you're going to choose a u. Find du, integrate, and plug back in. Yes. Yes. All right, so this becomes negative e to the, and what did we let u be? Cosine x. Do what? Okay, so what happens if I choose the other one? If I let u here be sine x instead of the other, then du would be cosine x. Well, that's not going to help me integrate because what I'd have is u e to the du. And that doesn't make a whole lot of sense, right?
How do you choose the right u?
You have to look at it and say which one. You'll have two. Okay. As you look at this, and I know I need to do a u substitution here because I've got this multiplied product. I've got this product to c multiplied, and I just don't even know.
What's the u substitution?
It's allowing us to find the antiderivative by making it a little bit easier. So if you look here, hopefully as you look, this kind of pops out to you a little bit as one being some sort of derivative of the other. Agree or disagree? Which one, if you had to pick one to be u, which one do you think would be u? Five plus two and three thirds. So you want du to be present in the integral, and you want to be able to write the u in there so that you can find an antiderivative. So in other words here, I noticed that this is a bigger power than this, right? But don't think about the square root. Could I not do this? What would du be? Du is what? No. Well, watch what happens. And I'm fixing to make it just slightly more confusing, so stay with me. The more we do, this is hard when you first see it, but once you get into the groove of it, it'll be a little easier. Remember I told you I need du inside, right? I can add values in there as long as I stay balanced here. So would you agree then? This is the square root of u, but it's not quite du. What am I missing from my du? A 6. So if I put du here, that means I've thrown a 6 in here. Do you agree? So you got to divide by 6 yourself. Okay. Ask me again, Dylan. What did you say? The derivative of u. What's the derivative of 5 plus 2x cubed? X squared outside. Well, what is du?
1/6 times 6x squared.
Right? So all I did here, let me try to write, I did the integral of the square root of 5 plus 2x cubed times 6x squared, but because I put this, this should actually have it. Because this has got this 6 in here, I've got to keep that value the same. So I'm also going to multiply by a 1 over 6, just to make sure, because it's still got to have this value, right? So I put it right out front. You're dividing by 6 because your du was multiplying by 6. Right. Okay, because the derivative was negative sine x, right? So we needed that negative 1. Is that what you're asking me? Why do we not do what? Well, you do, but you got to keep it with the same value. Yeah. Right. I know, y'all. I know this is tough. But can you find the antiderivative of this? Yes. What is the antiderivative of the square root of u? Okay, square root of u is what? Because I'm looking at. Is that what you feel like? Do y'all feel like this is random? Okay, could you, let me finish this and then ask, all right, 2/3. U was what, 5 plus 2x cubed? When you do the integral with the du, Okay, that's like when you find the integral of some function. Guess what?
At this point,
I would absolutely leave it like that.
I don't understand how we got it.
Okay. If I asked you what is the antiderivative of this, could you tell me?
I mean, I could.
Could you? Without the U substitution, could you tell me? I'm going to go with no, because that 5 plus 2x cubed is to the 1/2. You can't distribute it through. You can't get it written as a polynomial. So I couldn't go through finding. And there is definitely no way I would ever come back to this. Right? So I got to figure out a way to evaluate it. I have found that with this, the hardest part is determining what's going to be my u. Once you figure out what u can be, it's downhill from there. Because then, once you find the right u, it makes things a lot easier as far as evaluating the integral. I knew this was going to be tough. This and volumes of revolution are going to be our hardest two topics left. Okay, so this has got to have the same value. I cannot change this value. Do you agree? And because I have to follow with a du, I've got to include everything from my du in here. Well, the du had this 6 that wasn't in the original part, right? So if I take anything in the world and I multiply it by 6, to make it have the same value, I can multiply it by the identity, and it's the same. I did that so I didn't change its value.
Like the norm, if we're just canceling it out, why couldn't we just have the normal thing?
You didn't cancel the 6. You did that to keep the same value. It's kind of. Do you remember when we rewrote quadratics in vertex form by completing the square? And it was really hard for y'all to understand that we were adding the c, but then we were coming over here and subtracting the c on the same side. Because I needed to use it here. I didn't need to use it over here, but I had to include it to keep my value the same. It's the same kind of thing here. I need it for part of my du. But if I just put it in there, it's going to change the value. So in order to keep the value the same, I do the opposite also. I know that didn't, I know. Yes. Okay. Let me show you another one. Do what? You want to do another polynomial one? Okay, well, this is on your sheet. Cotangent's on your sheet. Go look at your sheet. This is one that's just going to it's just going to have us look at that you're struggling with, okay? The du part with the number in there. Well, you can't take the 7 out because it's hooked to the cotangent. In the front. For trig functions? No, you can't do that with trig functions. Okay. Now, when you first look at this, you go, but wait. I know the antiderivative of cotangent, right? Well, but it's on my sheet, right? What is the antiderivative of cotangent? Is it not on there? Some days are just, let me just go to your homework. No, this is definitely not a BC topic. What if I start you tonight by only giving you problems where they define the U?
Yes. Yes. I understand why.
For example, number 17. Use the indicated substitution to evaluate the integral. Confirm your answer by differentiation. So we're just going to check our work when we're done. It's all the same. So this is saying let U be 3x and evaluate the integral. So if I know that U is 3x, what do I know that du is going to be? And I'm going to throw that dx on there because it's actually 3dx, right? All right. So what is the antiderivative? All right, so I've got sine u, right? So that takes care of all of this. The only thing I have here is dx, but what do I need it to be? I need it to be a 3dx. Do you see that? So if I throw a 3 here, I can't just put it in there willy-nilly because I want to, right? I have to do something to counter it. What counters multiplying by 3? So I'm going to put that on the outside because that's a constant, that's a coefficient value that I don't even have to worry about right now. So I'm going to throw it on the outside. So now I have 1/3 times the integral of sine u du. Do we all agree? Based on my u and my du. Does that make sense?
So can you put 3dx in place of that du?
Say that one more time.
Yeah, when you're substituting.
Yeah. So this has to be, everything that du is has to be in your, you can't just throw a variable in there, but you can do numbers. Okay. All right. I just threw a 3 in there because I wanted this to be 3dx so that it would match my du.
So anytime you do has a constant, you have to
In the front, yes. Right. Because I changed the variable. Instead of dx, now it's du. Because your d has to be in respect. I want this with respect to the variable given in the integral. What is, well, I'm not done yet. What is the antiderivative of sine u? Negative cosine u, right? So now I have 1/3 negative cosine u plus c. What is u? You've got to plug that back in. So it's negative 1/3 cosine 3x plus c. Don't forget that c. They'll take points off for you for forgetting the c. When you take the antiderivative, you remove the integral sign. You only plug back in the u, not the du. Because the integral and the du, when I find the antiderivative. Okay. Another one. Hard or easy? That's dy.
So by du.
All right, so I would just put that in front because it's all multiplied. Yes, ma'am. It usually is. And it's also the one that if you took the derivative of it, it's the, okay. Try the most complex one. But you're not going to include exponents or other operations on it. In other words, if it was under a square root, we wouldn't let u be the square root of that. We would let u be what's under the radical. Right. Your goal is to get to where you can find the antiderivative easily. Okay. Okay, what is du? 4y cubed plus 8. All right, and we're going to take this step by step so everybody sees what's going on. I'm going to move this 8 to the front to start with, right? So I've got 8 times the integral of, and if you don't have to write this step, that's fine. If you want to, that's fine too. Y cubed plus 2y. So remember, I need all of this and I need all of that. Oh, dy, sorry. So what are they missing? That's right. This is obviously all u. But for du, I need it to be, they're missing the 4, right? But if I multiply here, I got to divide.
I was thinking 1/2.
Yeah, but I mean, it doesn't matter because this is the same thing as 4 times y cubed plus 2y. So now what? So I have 2 times the integral of u squared. So now it's 2 times, what is the antiderivative of u squared? And now all you have to do is plug back in. So anytime you have this is where you add 1 and then this gets divided by here. Antiderivative, right. So now I have 2/3. Go back to that original u, which was y to the 4th plus 4y squared plus 1 cubed plus 6. Yes.
Well, either way,
Hold up, Miss McGee, how is that a
What else do you think I need to write?
How did you only get this part, not the rest?
Yes.
How did you only get like that part and not that part?
Okay, so that was the du. All of this makes up the du, right? So if I asked you to find the integral of x squared dx, when you find the antiderivative, you just do 1/3 x to the 3rd, right? You don't pay any attention to that anymore because it's going with the integral. So once you figure out the du and you force the du, it never comes back into play.
Well, how did this have any play to begin with then?
Well, because I had to make sure that all of du was included in there. And it wasn't. I was missing that 4.
So you needed the 4 so that you could make the coefficient in front, right?
That's right.